All right, let's look at this short standard. This is your second time taking this over complex numbers. Okay, it's in the standard's name. So complex numbers means you're dealing with that I stuff. You need to know that I second is -1, and if you have a negative and a square root, you need to extract an I. Okay, just different number system. Okay. Now, the first one, you need to multiply these two. Think of it as two binomials. They're actually called two complex numbers, but it's the same concept as multiplying two binomials with the 1 and the 2. Okay? So we can't add, so I use the distributive properties. So 4 times 5, 4 times 2i, 6i times 5, and 6i times 2i. So that's 20, it's 8i, it's 30i, 12i squared. Remember, with I, any other letter, no. But with I, you need to replace the second powered I with -1. So -1 times 12 is -12. Okay, so here with the I, we have 8 and 30. That'd be 38. And then with the non, we go 20 and -12, and that's 8. So just multiplying the complex numbers, you just know. Okay, solve the equation for x. Two answers. Well, you got x second. You have x second only, so we're going to isolate x second. We're not going to do all that factoring nonsense. Okay, so you got to undo the +9. Or inverse operations. I call it isolate, but other people call it inverse operations to get the variable by itself. Okay, undo the -4 by dividing. That's -12. Then time for the second power to be eliminated with the square root. The second and the square root undo each other, and I have x. Remember, square root's positive or negative. Okay, you got a negative inside there, you do, so you need to bring the I out. And when we are isolating x squared, when I do the square root, I need to check my list, not on here. So I make 2 square roots. Okay, so 12 divided by 9, it'd be between 9 and 16, so 12 divisible by 9, no. Does it divide by 4? Yes. So 4 goes first, 3 goes second. You got 2, so you put 2 square root of 3, and if you had to use the letter I need to see that somewhere, okay? So those are the answers, 2i with a square root of 3, and 2i square root of 3 negative. Okay, last problem, 2 answers. I have the x squared, but I have x, so I can't isolate x squared using inverse operations. That's not going to work. You're going to unfortunately have to factor. So GCF and the T-chart. GCF, you got a negative in front? Nope. You got x on everything? Nope. 1, 3, and 14 is a GCF 1. A, B, C that, so it's A times C. 1 times 14, it's going to be 14 positive. Sum of 3. Good luck with that. You should pretty much know there's no factors of 14 that make a sum of 3. Okay, that's fail. Okay, so quadratic formula. Opposite of B, opposite of B, so -3 plus or minus the square root, B squared, so a 3 to the second, minus a 4, and then A is 1, and C is 14, and then 2 and 1. Alright, dude, so I got -3 in front. 2 times 1 is 2. Let's enter that in. The calculator, second, square root, double parentheses. 3 to the second, minus, and then 4, 1, and 14. Domain error. make the square root, and then enter that expression without doing the square root. So parentheses with 3 to the second minus 4, 1, and 14. That's why we have a domain error, because the calculator does not recognize negative square roots as the number system, and it's not. So it's our job to bring the I out, and we can find the square root of 49 on the calculator when using the quadratic formula. That's fine. 6.86i. Okay, two options. You can circle that, or you can write negative 3 plus 6.86i over 2. Negative 3 minus 6.86i over 2. Okay, 3 problems, but you got to make sure you know what you're doing. So x squared only is isolation. When you do the square root, remember to check if you need the I, which you will, and you got to do I want the list done on this. On the quadratic formula, you can use your calculator, but that's fine.